Hello friends, so today we are going to solve questions from the memory based questions from the session dated session 23 January and first and second session, and close to 27 questions we have to solve. Please remember, these are the memory based questions. So we are going to solve the questions from JEE Mains, and this was held on 23 January 2026, and for both morning and evening, and we are only going to solve the questions from physics. And please remember, these are memory based. And so there might be some problem with the statements, some data will be here and there, but you will get the basic idea about this paper. So in the first question, it states that an object is placed 8 cm and 24 cm from a convex lens. The magnitude of magnification is same in both cases. Find the focal length of the lens. So in this case, we are given that object is placed at 2 places, and in both the cases the magnification is same. So in this case, we are going to use the lens maker formula. Now we can say this as our lens formula. And this lens formula is our 1 upon V is equal to 1 upon F plus 1 upon U. And our magnification, we know the standard formula that M is equal to our V upon U. Therefore, based on this, we can also write that our V is equal to U times the focal length divided by U plus focal length. And we are only interested in the magnitude part. Therefore, we can write that the magnification magnitude will be equal to V upon U, and this can be also written as our F and U plus F. Okay. This is the basic formula for, you can say, the magnification only in the magnitude part. And we are given 2 positions of the objects. Okay. So we are given, let us suppose for the first case we call this as U1, that will be equal to minus of 8, and second case let us call this as U2, that will be equal to minus of 24. And we are given that for the first case, let us suppose the magnification is our M1. In the second case, the magnification is our M2. Okay. So let us write only the magnitude part, and it is given that both are equal. So therefore, we can write this as our F upon U1 plus F is equal to F upon U2 plus F. And from here we can easily write it as our U1 plus f is equal to u2 plus f, and therefore you can say that u1 plus f is equal to minus of u2 plus f, and from here we get that u1 plus u2 and plus 2f is equal to 0. Therefore we can say that our 2f will be equal to minus of u1 plus u2, and we already know this u1 and u2, so this comes as minus of minus 8 and minus 24. This will be equal to 32. Therefore we get that the focal length is equal to 16 centimeters. So this was our first question. Second question, it states that a block is placed on a smooth frictionless inclined plane making angle of theta with the horizontal. The block is given an initial velocity u up the inclined plane. Find the distance traveled by the block along the incline before it comes momentarily at rest. So in this case, you can just draw the approximate figure. So block is an inclined plane, angle of inclination is given as theta, and let us suppose the block is somewhere here, and it is given initial velocity u, and after some time, let us suppose it reaches this position and momentarily it comes to rest. Okay, and therefore it's quite obvious there will be a deceleration of this object as it is going to travel upward. Okay, or we can say that the acceleration along the plane will be equal to minus g sine of theta. Okay, negative means automatically the deceleration. Okay, or in simpler terms we can also say, because in the question it is mentioned that there is no friction, so it means the only force that will be acting or that will be slowing it, so force should be acting in the opposite direction to the direction of the velocity. Okay, direction of the velocity is up the inclined plane, so downward force will be the component of our g, that is our g sine of theta. Okay, and we can just draw it also. So this is our g actually, okay, and we can divide this into two components. This will be our g cos of theta, and this will be our g sine of theta, and this angle is theta. So you can say that there is no friction, and as there is no friction, so you can say the only force acting along the plane will be equal to g sine of theta. Therefore, you can write that acceleration along the plane, acceleration along the plane, let us suppose that is our a, and that will equal to minus of g sine of theta. And Now we can easily use the equation of our kinematics. So we have equation of our kinematics, which gives us that v square is equal to u square plus 2as, and suppose s is the distance at which it comes momentarily at the rest, and momentarily at rest means this final velocity will be equal to 0. So we get this as 0 is equal to, initially we know it is our angular velocity v u, and this will become minus 2g sine of theta times s. Therefore from here we get that our s will be equal to u square 2g, and this is our sine of theta. So this is the distance traveled before it comes momentarily at rest. Momentarily is written because there is no friction. So momentarily it comes to at rest, then it is going to slide in the downward direction. Okay, that's why it is mentioned as for moment. Next question. It states that a thin wire is bent to form equilateral triangle loop with each side of length 4 square root of 3 centimeter. A steady current of 2 ampere flows through the wire. Find the magnitude of the magnetic field at the centroid of the triangular loop. Okay, so this is a very interesting question, and for that here we are going to use a formula, and that is of our you can see a wire, and usually suppose we are going to find out the magnetic field at this magnetic field at point P. Okay. And so let us suppose the extreme ends are making this angle is alpha, and suppose this angle is our beta, and d is the distance, this distance is our d. Therefore we can write that magnetic field at point P, let us suppose that is our B, will be equal to mu naught I upon 4 pi d sine of alpha plus sine of beta. So this formula we are going to use, and so let's try to draw the figure which is given to us. So we are given a triangle, and we are going to find out the magnetic field at the centroid. So this is our centroid. Let us call this as A, B, C, and this centroid let us call this as O. And the current direction, let us assume this is the current direction. Current is I, and current will be flowing in this direction. So obviously the direction of magnetic field for each wire at the centroid will be same. And here we can also say, let us call this point as M. So we are going to consider triangle in this ABM. Let us consider this triangle ABM. This is the A, B, and M. Equilateral triangle is there, so this will be 60 degree. Therefore, we can find out what will be our BM, because we know this is our 4 root 3. So we can say BM will be equal to, this will be our 4 square root of 3, and we have this as our sine 60. So this gives us that BM is equal to over 6. But in this case, there is a, so this point is our O. and we know this centroid point, this divides in the ratio of our this Bm can be written as our BO ratio OM, and this ratio is our 2:1. Therefore, the actual length, we can say that our BO will be equal to 4 and our OM will be equal to 2. So we were able to find out that our length is BO, this is our 4 and this comes as our 2. So because this portion is equal to this portion, therefore this length will be equal to 2. So let us draw this our AB line. So we have our AB, this is our A, this is our B, and this is point O, and the perpendicular distance we just found out is our 2, which is our nothing but D in this case. The perpendicular distance between the line and the point, and we are going to join these two extreme ends. So one angle we are going to call alpha and other angle we are going to call as beta, and this length is about 2. This is length 2, and this whole angle is 60, so therefore this angle will be equal to 30. So we are going to have this angle is about 30 and this is about 90 degree. Therefore we get this is of 60 and this angle is over 60. So both alpha and beta are 60 and 60. And value of current we already know, current flowing in this direction, say current I. Therefore we can say that magnetic field at point O magnetic field at point O due to AB, and let us call this as B AB, and that will be equal to our mu naught I, and we have our 4 pi this is D is our 2 in this case, and sine of alpha is 60 plus other angle is also over 60, and so we can easily substitute it. This 4 mu naught upon 4 pi is about 10 to the power minus 7. This comes at 10 to the minus 7. Current is given as 2 and denominator is having 2, and sine 60, so this will be twice into 3 root 2, and so this 2 cancels out, and we get this is equal to square root of 3 multiplied by 10 to the power minus 7, and this is only because of this is B, not M. AB. Similarly, we can find out because of BC and because of our AC, okay, and all these will be equal because everything is same. So from here we can say magnetic field because of AB will be equal to magnetic field of BC will be equal to magnetic field because of our CA. Therefore, total magnetic field at O, let us call this as B, and that will be equal to 3 times magnetic field because of our AB, and so we get our B is equal to 3 root 3 into 10 raised to the power minus 7. So this is our value of magnetic field at the center. Okay. So in this case we used the standard formula A little bit calculation was required, but this question was last year also. There was almost similar question, almost similar, and in that case it was something like this. Something like this was it. And we are supposed to find out magnetic field here, if I remember correctly. So similarly, we use something like this. I'm not sure, but something question was there like this. So this type of concept is quite repetitive, and we have to take care of that. Next question. It states that the speed of the sound in the dry air is 0 degree centigrade is V. Find the temperature of the air. When the temperature of the air is increased, the speed of the sound becomes twice. Its value is 2V. Find the final temperature of the air in degree centigrade. And for this, in ideal gas, we know that our speed is directly proportional to square root of temperature. So we are going to use that relationship directly. You can say for ideal gas, our velocity is directly proportional to square root of temperature. Therefore, we can write that V1 upon V2 is equal to square root of T1 divided by square root of T2. V1 is given to us as V, V2 is given to us as a twice V, is equal to, and 0 degree centigrade, in Kelvin it will be 273 Kelvin. Therefore, you can say that our 273 upon T2 and square root. So this V and V cancels out, and we get this our T2 upon 273 is equal to 4, and therefore we get T2 is equal to 4 into 273, that will be equal to 1092, but here it is in Kelvin, and we are supposed to find out in degree centigrade, so minus 273. So this gives us our T2 is equal to 819 degree centigrade. So this is our answer. Okay, next question. This is a little bit, we can say, lengthy and interesting question, and it states that usually this question is asked every time. Most of the time we get this kind of question, but in this case there are, you can say, removal of the disk, and we have removed the disk twice. 2 disks are removed rather, not twice. So question states, a uniform disk has a radius r and a mass m. 2 small uniform disks, each of radius r by 4, are cut out from it. The center of 2 small disks are located symmetrically at a distance r by 2 from the center of the original disk along the diameter. The system rotates about the axis AA prime, which passes through the center of the original disk and is perpendicular to its plane. Find the moment of inertia of the remaining system about the axis AA prime. So basic figure is given to us. So we are having a disk, and then there is axis, and this axis is of A prime. And let me draw axis. And we are given that we have moved 2 disks. So one disk is somewhere here, and other disk is somewhere here, and this is our origin, and disk is our this the figure was given to us in question. I think I forgot to paste the figure. Anyways, so we are given that r is the radius, so this radius is given as r, and the radius of the disk is given as r by 4, and this is also our r by 4. Okay, so whatever calculation we are, let us call this as first disk, and this is our second. So whatever calculation we are going to do for the first disk, same calculation will be for our second disk. Okay. And it is being in this direction. So here we are going to consider that we are going to use basically parallel axis theorem, and for that we are going to consider, so let us consider our original disk, and there is no mass removed from it. Okay, nothing is being removed, and this is our A prime, and so we know that its mass is given to us as m, and its radius is our r. Therefore we can say its moment of inertia of the full disk, original disk rather, we can say that our moment of inertia of original disk, let us call this as I4, which will be equal to over 1 by 2 mr square. Okay. And first of all, let's find out what will be the mass of each small disk. So we have our mass of each small disk, and so mass per unit area. So we have our mass per unit area. So m was the mass of our capital disk, and per unit area will be equal to pi r square. And from here we can easily calculate the area of one small disk. So we can say that our area of one small disk, and that will be equal to over pi, and it was having a radius of r by 4. So this will be pi r by 4 whole square. So this comes as pi r square upon 16. Therefore the mass of small disk, let us call this as a small m. Therefore we can write that our mass of small m, we can easily divide them. So we get this as our m upon 16. So this is our mass of our small disk. Therefore the moment of inertia of one small disk about its own center, and please remember this is suppose our small disk, this is center, and let us call this axis as our b prime, and we have the disk, the axis through which we are going to find out the actual moment of inertia is our a prime. So in this case, first of all, we are going to find out the moment of inertia of this small disk with respect to its own axis, that is b prime, and we can easily find out this distance. Then we are going to use the theorem of parallel axis and find out the moment of inertia about the a prime. So you can say that moment of inertia of one small disk about b prime, which is its own axis. Therefore we can say, let us call this as our I1 is equal to, formula will be the same, half m and r square. Okay, so we have assumed this radius is a small r, which we already know. So this comes as half, small m we know is our m upon 16, and our radius is our r by 4 whole square. Therefore we get I1 is equal to our mr square upon 512. So we found out the moment of inertia of our this about the axis b prime. Okay. Now suppose this distance is our d. So this d distance is equal to our, because will be equal to 3r by 4. So this distance will be equal to, d will be equal to 3r by 4. Now we are going to use the parallel axis theorem. So we are going to find out now moment of inertia of one disk about a prime, and let us call this as our I a prime for disk number 1, and that will be equal to our moment of inertia about its center of mass, that is our I1, plus its mass and distance square. So I1 we already know is our mr square upon 512 plus small m is m upon 16, and distance is our 3r by 4 and whole square. Therefore we get moment of inertia about a prime for first disk will be equal to, and this will be coming equal to as 19 upon 512 and mr square. Now the second disk is same, identical. Okay. Therefore you can say that moment of inertia for I prime because of the second disk will be also equal to 19, 512 and mr square. Therefore we can write that moment of inertia of the system when both disks are removed, and let us call this as our I, will be equal to the moment of inertia of our original, and that is our I full. So we have this as I full minus moment of inertia about a prime because of first disk, plus moment of inertia about a prime because of our second disk. Obviously it is same. Therefore we can write that I is equal to I full is our half mr square minus, and it comes as our twice 19 upon 512 and mr square, and this will be our coming as 256, and 256 to this will be 128. So we get this as our mr square, 128 minus 19 and this comes as 256. Therefore we get that moment of inertia of the system when the two disks are removed is 109 upon 256 and m r square. And in this case, one important consideration is that wherever this location of disk number 1 and disk number 2 does not matter, as long as it is the angle doesn't matter, means they can be at any angle. Okay, suppose this disk is here somewhere, it will be same. This disk is here, it is going to remain same. If they are radii and everything is same, so angle doesn't matter. So there was also confusion about the location of this disk number 1 and disk number 2, means the angle with respect to this positive axis. So that doesn't matter, they can be at any angle. Okay, like the question that was presented to me, it says that they are along the diameter, okay. But some were saying that they were at a different angle, some were saying that it is somewhere here, but that doesn't matter. The angular position doesn't matter, as long as they are everything is same. Next question. It states that unpolarized light is incident from air onto a glass at a certain angle. The refractive indexes are 1 and 1.52. At this angle of incidence, the reflected beam is completely polarized, which is also called as a Brewster condition. Find the angle of refracted beam inside the glass with respect to the norm. So this question is basically, it is mentioned also here, that is called as a Brewster condition. So in this case, we can just draw an approximate figure for that. Suppose this is our boundary and we are having a normal, and at one particular angle, let us suppose this angle is our IP. So if and so you can say that from here, so we are having let us suppose this is our N1 and this is our N2. So N1 is our air and N2 is our glass. Therefore, there is a Brewster condition which states that if this condition is maintained, means tangent of this angle I of P, if this condition is being maintained, which is our ratio of N2 upon N1. For this particular condition, there will be two waves. One wave that will be coming back to the air, this is called as polarized light, and the other wave, a light, will be partially refracted, and that is called as a partially polarized light. And the angle between this polarized light and partially polarized light will be always equal to 90 degrees. So this you have to remember. And in this case, the angle is not given, but we can find out from this ratio. So let us first of all, and we are supposed to find out this angle, and we know that the angle of incident, and this will be equal to over also I of P, and therefore we can say that this angle will be equal to 90 minus I of P. Okay. Therefore, we can further write that, let me erase this part. So you can further write this particular angle will be equal to nothing but our I of P. This is our N2 and this is our glass. Therefore, if this angle is our suppose refracted angle, let us call this as R of P, then with respect to this I of P, we can write this as 90 minus I of P. So this is a, you can say mathematically, we have this type of various angles that is associated with this Brewster condition. Okay? And that states that the tangent of this incident angle I of P will be equal to the ratio of our denser medium to the rarer medium. N2 is our glass, N1 is our air. If this condition is maintained, then the light ray will be partially reflected and partially refracted, and the reflected will be partially polarized. No, it will be polarized light completely, whereas the refracted will be partially polarized. Okay, and angle between the partially polarized and polarized light is always equal to 90 degree. Okay, so this is the basic. Okay, usually it's a little bit confusion, and we can just find out all these angles. So if you substitute value of this N1 and N2, we can write that our tangent of IP will be equal to 1.52 upon N. This comes as 1.52. So we get that the angle IP will be equal to tangent inverse of 1.52, and this comes approximately equal to 57.3. And like I said, we are supposed to find out this RP, and this RP will be equal to 90 minus IP. Therefore, you can say that our RP will be equal to 90 minus IP. So straightforward, we are going to get this as a 90 minus 57.3, and this will be equal to 32.7. Okay, that was asked for. We are supposed to find out the angle of refracted beam to the normal. Okay, that is our R of P. So a little bit tricky part here, how to find out, but if you know the geometry, we can easily find out using the geometry. Only thing that for Brewster condition, because it says that it is completely polarized. So this ray is completely polarized, and this refracted is partially polarized. Okay, and the angle between them will be always 90 degree. This is our Brewster condition. According to, if this condition is maintained, the tangent of IP is equal to this. Next condition. So it states that a parallel plate capacitor has a plate separation 5 mm, is connected to battery, so the potential difference across the battery remains constant. A mica sheet of thickness T, that is 2 mm, is inserted between the plates. Okay, and this was actually not part of the question, it was part of the solution. Okay, we can add this in solution part. After insertion, the capacitor draws 25% more charge from the battery than before. Find the dielectric constant or relative permeability K of the mica. In this case, we have to remember that battery is remaining always connected with the parallel plate of capacitor. Okay, battery is not being removed, and the mica sheet, or we can say dielectric, is inserted with the battery connected. Okay, we are not removing the battery. Okay, this plays important part here. So let us consider our if, because battery is always there, so the voltage V will be always present across the capacitor. Okay. So we can say that our initial charge let us call this as a Q naught, will be equal to initial capacitance and voltage, and final charge is, let us suppose, our Q. Then this Q is equal to, capacitance is going to change because mica sheet is inserted, but voltage is going to remain same. And it says that it draws 25% more charge. Okay, so we can find out the relationship between our Q naught and Q. So we are given that charge increases by 25%. Therefore, you can say that our final charge is equal to 25% of our Q naught. This comes as 1.25 of our Q naught. Okay, please remember, initial means without dielectric, and final means with dielectric. This is the difference between initial as well as our final. And so let us substitute this Q and Q naught in terms of our CV. So our Q is our CV, and this comes as 1.25, and Q naught is our C naught times V. So V and V cancels out. So this gives us that the final capacitance with dielectric is equal to 1.25 of C naught, which was our without dielectric. Okay, naught means no dielectric. And we can we know the formula for our C naught. So we can say our initial capacitance means without dielectric, without mica sheet. Without mica means only air. And we can write that our C naught will be equal to epsilon naught A upon D, and we can write this as our epsilon naught A, and D we know is our 5 into 10 to the power minus 3. And now we come to our dielectric is introduced, that is mica sheet is introduced. So we can say that our capacitance after inserting mica, which is our dielectric, and its thickness is given to us over 2. So we have to remember that this is, suppose, our capacitor, and the voltage source is always being connected, it is not being removed. So this is always V here, and when mica sheet is inserted, let us suppose this is our mica sheet insertion, and this thickness is our T. So if D was our original thickness, then the remaining thickness in which the air will be present will be equal to our D minus T. Okay, and this both with, so we are going to have two capacitors here, one with mica sheet as a dielectric and one with the air as dielectric. So this is air dielectric and this is mica sheet, and both will be in series. So this is the basic thing what is happening here. And please remember, the voltage source is always connected, it is not being removed. Therefore from here we can write that capacitance after inserting mica, we get that our capacitor behaves as two capacitors connected in series. And with mica, so we have first as our dielectric as with mica. Let us suppose the capacitance is about C1. So this comes as dielectric constant epsilon A, and its thickness is our 2. So this becomes 2 raised to the 10 raised to minus 3. And then we are having the second one is our with air as dielectric, and let us call this as C2. And in this case we can also use dielectric constant, but we know the dielectric constant of K air is 1, so there is no need to write it. So this comes epsilon A, and the thickness comes as D minus T, and that comes as 3 into 10 raised to the minus 3. Now this C1 and C2 will be in series combination. Therefore we can write that for series combination, one upon Cs is equal to 1 upon C1 plus 1 upon C2, and this is quite easy to solve. We can just simply substitute it, so we get 1 upon Cs will be equal to, and it gives us K epsilon A, and this is 2 into 10 to the minus 3 plus, and C2 is epsilon A, and this is 3 into 10 to the minus 3. And we already know the, can say, the relationship between the two. So let us sort it out first. We can take 1 upon epsilon A as common, and this comes as 2 into 10 to the minus 3, and we can take 10 to the minus 3 also. I'll leave it as it is. This comes as K plus 3 into 10 to the minus 3. And we already know, one second, okay, it is C. Let me keep this C then, otherwise it is, so this is C with mica. And we know that our C, we already found out that our C is equal to 1.5 times C naught, or we can say that 1 upon C is equal to 1 upon 1.25 C naught, which gives us 0.8 times C naught. And we already know the value of our C naught, so we know that our 1 upon C naught is equal to epsilon A, and this comes as our 5 into 10 to the power minus 3. So we can easily sort it out. So this comes as our, so 1 upon C, we can replace it by this value and multiply by 1.5. Therefore we get 1 upon epsilon A is 2 into 10 to the minus 3 upon K plus 3 into 10 to the minus 3, and equal to 5 into 10 to the minus 3 upon epsilon A multiplied by, one second, yeah, mistake is something, 1.25, one second, yes, this is 1.25. So rest is, this is okay, this and this comes here multiplied by 0.8 now, and you can cancel out, this goes away, and this also cancels out. Therefore we get we get this as our 2 upon k plus 3 will be equal to, this is 5 into 0.8, that is equal to 4. Therefore, we get this as 2 upon k is equal to 1, or we can say that our value of k is equal to 2. So, this is our value of our dielectric constant. Next question. This is quite straightforward. It says that electric permittivity of the medium, that is ER, is 3 times that of free space. Magnetic permeability of the medium, that is mu r, is 2 times that of free space. The ratio of speed of light in the vacuum to the speed of light in the medium is. So we know the general formula, that speed of light in any medium, speed of light in any medium, suppose that is our v, then this v will be equal to square root of mu times E. Okay. And for vacuum, the speed of light is denoted as c, and this c is equal to our absolute permittivity and absolute magnetic permeability. And therefore, we can write that in medium, suppose our velocity is our velocity medium, then this will be equal to 1 upon our mu r, mu epsilon, and epsilon r and epsilon naught. So this comes as our c upon the relative. More, if you know the relationship, this relationship we should be knowing directly, but if you don't know, we can just calculate it. Okay. And we need to find out their ratio. So we can say c upon velocity in the medium will be equal to the square root of the product of the relative, and this comes as about 2 times 3, which is about square root of 6. Next question. It states that a metallic sphere with a diameter 2 mm and the density 10.5 gram per centimeter cube is dropped in a glycerine which has a viscosity of 10 poise and a density of 1.5 gram per centimeter cube. Find the terminal velocity attained by the sphere, given that pi is 22/7 and g is 10 meter per second square. Okay. So, in case of terminal velocity, we always have to remember that our net force on the body, which is traveling at a terminal velocity, will be equal to the drag force. That we have to remember. Okay. Or in simpler terms, suppose this is the body, okay, and it will be moving in downward direction. So in upward, it is going to have two forces. One will be our, in the downward it will be mg. Upward we are going to have our this buoyant force, and we are going to have a drag force. And at terminal velocity, the acceleration is equal to 0. Therefore, we can say that our net force will be equal to basically our drag force. Therefore, we can write that our at terminal velocity, our net force is equal to our drag force, and net force is our mg minus the buoyant force, that is our drag force, that is given by the Stokes law, and that is our 6 pi mu r times v, where v is our terminal velocity. And we can find out our mg. Mg is equal to our density of the sphere multiplied by volume multiplied by g, or we can say this is rho s multiplied by 4 by 3 pi r cube multiplied by g. And our buoyant force, that is a Fp, will be equal to density and of the fluid multiplied by our volume multiplied by g. Volume is volume displaced, that will be same in both cases. So this is rho, and it comes as 4 by 3 pi r cube multiplied by g. So we simply substitute them. So we get this as density of our sphere or solid times 4 by 3 pi r cube multiplied by g minus density of our fluid and volume displaced, because that is a buoyant force, 4 by 3 pi r cube multiplied by g is equal to over 6 pi mu r times v. And we can just sort it out. We could take this as 4 by 3 pi r cube times g as common, so this becomes density of a sphere minus density of our fluid is equal to 6 pi mu r times v. Therefore we get that our terminal velocity will be equal to, we can cancel out here pi, and we can also cancel out from here, this will be coming as 2, this will be coming as 3. Okay. Yeah, so, and this will become a square, and this goes by r. Therefore we get the velocity will be equal to 2r square g difference between their densities and divided by 9 and viscosity constant, and all the values are known to us or given to us. So this comes as our 2.001 whole square, and this comes as our density is given as 10.5 and 10.5 and 1.5. So this comes as a 10.5 minus 1.5, and 9 times it is given as our 1. Therefore we get that our terminal velocity will be approximately equal to 2 centimeter per second. So this is our terminal velocity. Okay. So for terminal velocity, the concept is quite easy. Okay. If you don't remember the formula, we have to remember that the drag force formula we have to remember, and upward force will be our buoyant force, and the drag force when the body is traveling in the downward direction, and the downward we are going to mg, and everything will be in equilibrium. Okay. So the net force will be equal to drag force. That's the basic solution for that. Okay, so this question was from the dimensional analysis, and it was a little bit tricky part here. Okay. So we will come to that, and it states that the time taken by a small spherical ball to attain its terminal velocity while falling through a viscous medium is given by this relationship, where r is the radius, density, medium, and coefficient viscosity, and k is a dimensionless constant. Find the value of a plus b plus c plus d. Okay. But in normal circumstances, we know that our dimensional analysis consists of only M, L and T. Okay, we have basically three variables that is associated with our dimensional analysis. But in this case, we are going to find out what will be the addition of four variables. Okay, so this is a little bit tricky here, but solution is quite easy. Okay, we have to remember, because in this case also we are going to use the concept of terminal velocity or formula for terminal velocity. So let us start with the basic part, which we will do, then we come to our how to solve them. And for that we know that we are going to start with our left side, that is dimension of our time. The dimension of our time, that is our t, will be equal to capital T. That's quite obvious. And then we come to all the parts which are mentioned here, their dimensions. R is the radius, so we can say our radius is going to have our L, length, then is our density, which comes as our ml minus 3, and other one is also density, so obviously density is going to remain same. And then we come to our this viscosity constant, and its dimensional we should be knowing actually, that will be equal to nu, and it is going to have a dimension of m l minus 1 and t minus 1, and we are going to substitute it in the given equation. That's our standard process. So from here we get that our t is equal to, and we have our L raised to power a, and we have our m L minus 3 whole raised to power b, and then we having our m L minus 3 whole raised to power c, and then we have our m L minus 1 t minus 1 and whole raised to power d. And we can just sort it out. We just open it as our standard procedure. So we are going to get our m, and the raised power will be our b plus c plus d. So basically b plus c plus d, and then we come to our L. L will be equal to a minus 3b minus 3c and minus d, and we come to our time t, and my time t will be equal to minus of t, and on the left side we are only having t. So we are going to get on the left side the dimension of our this m0. Therefore we can say that b plus c plus d will be equal to 0, and for length is also 0, so we get a minus 3b minus 3c minus d is also equal to 0. But for time t we are going to get minus of d is equal to 1, which gives us that our d is equal to minus of 1. So we found out that our d is equal to minus of 1. And let us assume this is our equation number 1 and this is equation number 2. So we are going to substitute in equation 1. So we can say from equation 1 we get b plus c is equal to minus of d, which gives minus of minus 1. Therefore b plus c is equal to 1. Similarly, from equation 2 we get this as a minus 3b 3c and is equal to d, which is equal to minus 1. And from here we can write that our a is equal to 3, we can take as common, and this comes as b plus c, and this is equal to over minus 1. and we know that b plus c is equal to 1, so this comes as our 3 minus 1, which is equal to 2. Okay, so we got that our a is equal to 2. Okay. So far we are able to find out that value of a is equal to 2 and d is equal to minus 1, and the problem lies that b plus c is equal to 1. Okay, this is the main problem. Okay, because we usually know that number of variables should be equal to number of equations, then only we will be able to solve it. Now we come to our main equation, that is our terminal velocity, which is our Stokes law. From there we are going to find out you can say this, how this b plus c is going to, or b or c, how we are going to find out. So we can say from Stokes law, we can write that characteristic time to reach terminal velocity characteristic time to reach terminal velocity is, let us suppose, our t. Then this t can be approximately equal to our m upon 6 pi mu upon r. And in case of mass, we can write as our density r cube. Okay, and this comes over mu upon r. Okay. Or we can say that this is equal to density r square upon mu. So from here we can say that our time, that is our t, it only depends upon density of the ball, that is rho. It depends upon density of the ball, which is nothing but rho. Or we can also say that this time t is independent of density of the medium. Density of medium, which in this case is our sigma. Okay, so this is important part here. So our time t is only dependent upon the rho, it is independent of our sigma. Therefore, under this condition, we can say that value of b will be equal to 1 and the value of c will be equal to 0. Now we got all the values. We got that value of a is equal to 2, value of b is equal to 1, value of c is equal to 0, and value of d is equal to minus 1. And we are supposed to find out a plus b plus c plus d, which will be equal to 2. This will be 2 plus 1 minus plus 0 minus 1, giving us 2. So this is a little bit tricky part to find out b and c. Okay, but question was solvable. And okay, next question. So we are given that 4 charges are kept as shown in the figure. Find the magnetic field, magnitude of electric field at point P. Point P is the midpoint of line AB. Basic figure is given to us. So we have a line and there are 2 charges. One charge is here, other charge is here. This is minus 4 microcoulomb, sorry, plus 4, and here it is minus 4 microcoulomb. And this point is A, and the distance between these 2 charges is given as 1 centimeter. There is another group of charges that is at B. One charge is here at -2 microcoulomb and other charge is, one second, this is one charge and other charge is somewhere here, that is about +2 microcoulomb, and distance between these two is given as 1 centimeter, and we are having a P point. This is our P point, and the distance between this AB basically is given as 80 centimeter, but is mentioned that our P is a midpoint, therefore we can say this distance is equal to 40 centimeter and this distance will be equal to also 40 centimeter. So this is the basic question, and we have to find out the magnetic field magnitude of electric field at point P. So in order to solve this, we can use two different methods. Okay. One is our normal process of using single charge and find out electric field at point P. So first we take +4, find out electric field at P, then we take -4, find out electric field at P. Similarly, take -2 electric field at P, +2 electric field at P. But if you look closely, these are nothing but two independent dipoles. This -2 +2 is a dipole, and this is consisting also of a dipole. Okay. So if we use the dipole, we can get the answer, you can say, comparatively easy. Not easy, but in the shorter time. If we consider our electric field, that will take a little bit of more time to solve, but we are going to get the answer. And basic concept is always going to remain same. So let me explain the electric field part. So we have this as our +4, and we have a point P here. So obviously the electric field, because of +4, will be in this direction. Let us call this as E positive. And then we are having -4, and the electric field, because of this -4, will be in this direction. So let us call this as E minus. Okay, and let us call this as P point here. So we are having two electric field, but their magnitude is same. Okay, let me reduce this. So this will be our E positive and this is our E minus. So because of these two electric fields, we can find out their net magnitude, or the resultant will be in this direction. So we get this as our E. Let us call the resultant of this as our E1. And then we are having this -2 and +2. So this is our -2. So electric field, because of this, will be along in this direction. So this is our E minus, so this will be E +4 and this is +4, and let me call this as a E4. This will be -2, E -2, and then we are having our this charge of +2 somewhere here, and electric field will be once again in this direction. Therefore, the net electric field, because of this both, this will be over E +2. This electric field we are going to get in same direction, that is E2. Therefore, for point P, this is our E2 and this is our E4. So net electric field at point P will be this E, which will be equal to our E square plus E4 square and its square. So this is basically how we can solve using our the electric fields. Okay. but it is much more convenient if we use our dipole. Okay, we can solve it in much shorter time. That's the only difference. Otherwise, the solution will be same. So let us solve it by using the dipole. So we have for dipole at A, you can see for dipole at point A, and let me draw it. So we are interested in this point P, and this is our dipole. This is positive and this is negative, and this is our A point. So for dipole at A, let us say that its dipole moment is our PA. Therefore, we can write that our PA will be equal to our Q times D, because our this point P is on the axial of this dipole. Okay, this is +4 and -4. Okay, remember, this point P is at the axial of the dipole. So we already know this 4. So this is 10 raised to the power -6. Distance we know is our 0.4. So we get our PA, that is dipole moment, because of this dipole at A, will be equal to, this will be coming as our one second. Yeah, this is 4. Okay. So this comes to as our 1.6 into 10 raised to the power -4. Now we come to our dipole at B, or dipole at B, and let us call this dipole moment as our PB, and we can say that our PB once again will be equal to Q times D, and that comes as our 2 into 10 to the power -6 times 0.01, which comes as our 2 into 10 raised to the power -8. One second. This is 0.4, 40 centimeter, 80 centimeter, 1 centimeter. Yeah, this looks good. Mm. 2 10 to the -6.1, 1 second, 1 centimeter, 40 centimeter. Yeah. Okay. Now we have to remember this point, our point B is on the equatorial line of our dipole. Okay. So let's find out the field, respective field, because of our dipole. So we can say our field due to dipole at A, and we are going to find out our point P, and this point P is at equatorial line. Therefore, we can write that electric field EA will be equal to our K dipole moment upon R cube, and K is 9 into 10 to the power 9 multiplied by PA is our 1.6 into 1 second, something problem. 81 centimeter. This looks good. I think there is no problem. And this comes as 1.6 into 10 to the power minus 6 upon r cube, that is 0.4 whole raised to the power cube. And this will be approximately, I think, this our EA will be approximately equal to 5.6 into 10 to the power 3. Okay. Now we come to a field due to dipole at B. And in case of this, the direction, so this is our point P. So dipole moment will be in the upward direction because of the this dipole at A, and the electric field is in the opposite direction, that is our EA. Now we come to our field due to dipole at B. Field due to dipole at B, and we have to remember this P line, P point rather, is on the axial. Therefore, we can write that electric field will be equal to, this comes as K twice dipole moment divided by r cube. Okay. And in case of this dipole, if you look closely the derivation part of it, there is a more of approximation is there. Okay. So the answer you are going to get is little bit of approximated. Okay. And so we get this 9 into 10 to the power 9 multiplied by twice, and dipole moment we got it as 2 into 10 to the power minus 8 and divided by 0.4 whole cube, and this EB will be approximately equal to 2.25 into 10 to the power 5, and so this is our point P and this is our B. So dipole moment will be our PB, and electric field, so this will be giving us electric field. So we have same result. So we found out electric field due to dipole is our EB, and electric field due to our dipole at A is our EA, and this is our point P. Therefore, the resultant will be in this direction, that is our net electric field E. Same solution or same answer we are going to get by this. Therefore, we get that our electric field E will be equal to EA square plus EB square and its square root, and our EA is our 5.6 into 10 to the power minus 3 whole square, sorry, not minus 3, plus 3, plus EB is 2.25 into 10 to the power 5 and whole square and its square root. So it will be approximately equal to 2 something, 2 raised to the power 10 to the power 5. Okay. So we can solve the same question by using the electric field as well as dipole. Dipole is going to get you the approximate answer. Electric field more or less gives us the exact answer. But electric field solution is much more lengthier as compared to our this dipole part. Next question. It states that mole of diatomic gas is expanded isothermally from V to 2V at 27 degrees centigrade. If the magnitude of the work done by the gas in this case is same as the work done in an adiabatic process, when the initial temperature is 27 degree and the final temperature is T degree centigrade, find the value of T. So, work done in isothermal is equal to work done in our adiabatic. Okay. So, let us start with the work done part only, then we can move forward. So, we can say that work done in isothermal, work done in isothermal process and let us call this as Wi, and we can write this as our work done for isothermal will be equal to our N R T what's the temperature given to us, 27 degree centigrade, and we have this as our T1, natural log of volume final and volume initial, and volume we know it is given that changes from V to 2V, and so we get this as our 1 mole is given, so 1 multiplied by our R, temperature is 27, so that will be 300 Kelvin, and the natural log of this comes as about 2V upon V. Therefore, we get our work done in the isothermal process is equal to 300 R and natural log of 2. Now we come to our work done in a adiabatic process. So we can say that work done in adiabatic is, let us suppose, WA, then this WA will be equal to our NCB TA minus TB upon 1, and this will be equal to our, we can say in terms of initial and final we can write it, we can say NCB, we have temperature initial minus temperature final, and initial temperature is same, that is we can say our W adiabatic is our 1 times our C of V, and initial temperature is our 300, final temperature is our T, which we are going to find out. Okay. And I think I missed something. Huh? I missed gamma. One second. So this is our gamma minus 1, gamma minus 1, and this comes as our NR, and this is our NR. This comes as our R. Gamma we know is our 7.5, which is 1.4, we can say our 1.4 minus 1. I think this will be correct now. And so, one second. Temperature we need to find out in degrees centigrade. So we can just modify this part also. Yes, so you can say this will be equal to our R multiplied by 300 minus T, and this will be 0.4. 0.4 we can write this as 5.2. Okay. Now we can just equate the work done. We are given that work done in isothermal is equal to work done in adiabatic. So we get this as our 300. Natural log of 2 is equal to 300 R. R, and this is about 300 minus T, and you can solve this. This will be 600 divided by 5, that will be our 120. 600 divided by 5, yeah, 120. R and R cancels out, so this comes as a 120. Natural log of 2 is equal to 300 minus T, and therefore we can write our T will be equal to 300 minus 120 natural log of 2, and natural log of 2 is approximately equal to 0.69. Therefore we can say that value of T is equal to over 300 minus 120.693 will be approximately equal to 3.16, and we are required to find out in degree centigrade, I think. Yeah, final temperature is also in degree centigrade, so we can just modify it. So this will be coming as our T, and we get this as our 300 and 273, which will be giving us 27 minus 83.16. So we get value of T is equal to minus 56.16 degree centigrade, because the answer is asking me degree centigrade. Next question. Okay, so this was about the total internal reflection. It states that a prism with the angle of prism 75 having refractive index square root of 3 has a slab of refractive index 1.5 kept on one side of prism as shown. Find the angle of incidence such that total internal reflection occurs at the slab prism interface, given sin 50.25, sin 25.43. So basic figure, you can just draw it. So we have a prism, and to one side this is having a slab connected something like this, and we are having a incident light, and which will be traveling something like this, and here it is said it should be a total internal reflection. Okay, it should not be going here, and angle of this prism is given to us as 75. Here it is square root of 3, and this mu is our 1.5. This is the basic things which are given to us, and we should be knowing that for our total internal reflection, that is our for the interface of slab and prism, the angle of incidence at the interface must be greater than or equal to the critical angle. So we are very much interested in the interface. So this is our interface. And so if I draw, suppose the ray is coming something like this, and there is a normal. Suppose this is the normal. Okay, so this will be our angle of incidence at the interface. Let us call this our theta for the time being. Therefore, we can say that for total internal reflection, the angle at the interface, incident angle, that is our theta, it should be greater than or equal to the critical angle. Okay, then only the total internal reflection is going to take place. Or we can say then when theta is equal to the critical angle, then the ray of light just grazes the surface. Okay. So this condition gives us the graze of our light. But we are interested in this part. And we can easily write out the formula for our this critical angle in terms of the refractive indexes. So we can say that for critical angle theta c, for critical angle theta c, we can say that our this sine of theta c will be equal to our n2 upon n1, and this will be equal to our 1.5 upon square root of 3, and this comes as our square root of 3 by 2, and therefore we can say that our critical angle will be equal to our 60 degree. Okay, because at critical angle the angle of refraction is equal to basically 90 degree. Okay, so sine 90, this is basically you can say this is written with the help of Snell's law. Only the sine 90 is equal to 1. So it means for total internal reflection occurring at slab prism interface, the angle of incident at the interface must be at least 60 degree. Okay. And this is at our this is slab prism interface. Slab prism interface. Now we come to our basic geometry of our prism, and we know that this is our prism, and for incident light something like this, it's a normal, and it is going to travel something here, and this is the normal on the other end. And if I say angle of incident is our I, then this is our angle of refraction I1, and this is our angle of refraction our R2. But for this particular case, our R2 is equal to our theta c. Okay, because we already drawn this is our theta c. So for this particular case, R2 is equal to theta c. And we have, let us call this as our point A. So if we use Snell's law at point A, you can say Snell's law at point A. Okay. So we can say that our sine of incident to our sine of our refraction, which is our R1, will be equal to, and this is our square root of 3, and air is having refractive index of 1. So this comes as square root of 3 upon 1. Therefore, we can write that our sine of I is equal to square root of 3 times sine of our R1. Okay. And we are also given that our angle of prism is our A. So this angle of prism is also given to us. Okay. So in this case, let us call this point as our X, because A and A is going to create. So this is X. So this is our angle of prism over A. And from the slab prism interface, we can write that our angle of prism, that is our A, and our relation between incident angle and our refracted angle. So we can say that we are having one second. Yeah. So you can say for prism with angle of prism as A, so we can write that our R1 plus R2 is equal to our A, and R2 is nothing but our theta C, which is our 60. Therefore from here we can say that our R1 angle of prism is given 75 minus 60 is equal to our 15. Now we can easily substitute here. Therefore we get that our sine of I is equal to square root of 3, and we have sine of 15, and sine of 15 is given to us. So this comes as square root of 3 times 0.25. So we get that our sine of I, and square root of 3 is approximately 1.3, so this will come in as 0.433, and sine of 25 is approximately 0.43. Therefore we can say that our I is approximately equal to 25. And for total internal reflection, specifically the value of I should be less than equal to 25. This condition is to be satisfied. Okay, then only the total internal reflection is going to take place. Next question. Next is given as find the truth table of given circuit. So let me draw the circuit. So we are having this is the OR gate, and this is our NAND gate. So this is our A, B, and this is our Y. So this is our OR gate, and this is our NAND gate. So we have two approaches to solve this. We can use our 0-1 put and get the answer and get the solution, but the easiest one is finding out the expression of our output, that's our Y. That is going to help us. So we have two inputs for the OR gate, so its output will be equal to A plus B, and here output will be equal to A, and let us call this our X. Therefore we can say that for OR gate we can write that our output X will be equal to a plus b, and our final output y will be equal to a NAND. Sorry, this will be a NAND x, and therefore we can say that for NAND gate, this was for OR gate, for NAND gate our y will be equal to a NAND x, or with the help of equation we can write that y is equal to over a multiplied by x and its complement, and we can substitute value of x, so we get this as a plus b and its complement, and we can use the property. That property gives us that this will be equal to a and a times b, and this is complement, and our a times a will be always equal to over a. So you can say this is equal to over a plus a multiplied by b and its complement, and we can take this a as common from here, so this comes as 1 plus b times complement, and this 1 plus b will be always equal to 1. Therefore we can say that our y is equal to our a complement. Now it is much more easier to design the truth table, and sometimes it is a little bit typical to understand the properties, so we can just use the logic of ones and zeros. For example, I wrote that my a times a will be always equal to a. In order to find out, let us take that our a, because these two will be same, so either a will be equal to 0, 0, so their product will be equal to 0. Okay. So this I have taken that value of a is equal to 0. Okay. So we got that a is 0, second one is also a, which is 0, so their product is equal to 0, which is itself equal to a. And in the second case, I take my a as equal to 1, so this comes as 1 multiplied by 1, which will be equal to 1, which is nothing but our 1, which is a. And in this case also, 1 plus b, I wrote this is equal to 1. Okay. It means that there are two possibilities of b. Either b will be equal to 0, so 1 plus 0 is always equal to 1, or b will be equal to 1, and 1 plus 1 is also equal to 1. So my 1 plus b is always equal to 1. So this is the basic. We can, if we do not remember the property, we can just solve it like this. Okay, because digital is ones and zeros always. So it is quite easy now. And we know that our y is dependent upon our a only. So we are having ab, and this is our y. Okay. And so let me write this is 0, 0, 0, 1, 1, 0, and 1, 1. And please remember, y is only dependent upon a and its complement. So a is 0, so it is going to give me 0 complement, which is equal to 1. Once again, a is 0, 0 complement is equal to 1. A is 1, 1 complement is equal to 0, and a is 1, 1 complement is equal to 0. So finally, we are going to get 1, 1, 0, 0. So this is much more shorter and easier also. It solves two purposes. Once you are able to find out the truth table, and second, because in most of the cases sometimes the question is asked about find out what will be the Boolean expression for our output. So it solves two purposes. You are able to find out the expression for our output, and from there you are able to find out the truth table also. Okay, so it solves two purposes, so it is much more convenient to solve it. Next question. It states that an air bubble is moving upward from the bottom of a lake having a temperature 17 degrees centigrade, At top, the temperature of the lake and the bubble is 27 degrees centigrade. Assume no significant change in the density of the lake water up to the depth of 5 meters. Find the ratio of the volume at the top of the bottom to the bubble. So we can find out the ratio when the our bubble is at the top and when it is at the bottom. And we have to remember that as the bubble is going to rise from the bottom to the top, two things are going to change. One, it is going to experience a change in the pressure, and it is going to also experience the change in temperature. Okay. So both things are it is going to experience. But we will come to the later part. First of all, let's find out what will be the pressure at the bottom of the lake. So you can see pressure at the bottom of the lake. Let us call this as P bottom, which will be equal to a P ATM plus the pressure due to liquid column, and liquid column, let us suppose, is a height of h. And so we can find out about our rho GH. Okay, rho GH will be coming close to as 0.494 ATM, and P ATM we know is our 1. Therefore we can say pressure at the bottom will be 1 plus, and this rho GH will be equal to approximately 0.494. So we can say this is close to our 1.5 ATM. We say approximately. And now let's come to our this temperature part. And bottom temperature is 17 degrees centigrade, top temperature is given as 27 degrees centigrade. So we are given that temperature at the bottom is our 70 degrees centigrade, which is our 290 Kelvin, and temperature at the top is equal to 27 degrees centigrade, and which is our 300 Kelvin. So we can use our ideal gas law, okay, because we can assume that number of, or we can say the amount of the gas or number of moles remains constant. If we can say for ideal gas, we can write this as a P1 V1 upon T1 is equal to P2 V2 upon T2, and we can write this in terms of top and bottom. So we can say pressure at the bottom multiplied by volume at the bottom, temperature at the bottom is equal to pressure at the top, volume at the top, and temperature at the top. And we are interested only in ratio of the volume at the top and volume at the bottom. So this gives us pressure at the bottom, pressure at the top multiplied by temperature at the top and temperature at the bottom. We can easily calculate the ratio, and we get this as top and bottom is equal to pressure at the bottom is approximately 1.5, top is 1, and this comes as 300 and 290, which comes as approximately equal to 1.5. So this is our approximation, that is the ratio which we are supposed to find out. Next question. Okay, so this gives us two blocks of 15 kg and 25 kg moving towards each other with speed of 6 and 10 undergoes inelastic collision. If the specific heat of both the blocks material is S, then the rising temperature of the blocks is equal to, okay, initially both blocks are at same temperature. So we are given that we are in two blocks. suppose this is about 15 kg and this is about 25 kg. They are moving towards each other, this with 6 and this with 10 meter per second. And it is given that the collision is inelastic, so it means the kinetic energy will be converted into form of our heat during the collision. Okay, that heat is going to raise the temperature, and from there we are going to sort it out. So let's use our start with momentum. So we can say our initial momentum, which is our P1. Let us suppose this is our M1, M2, V1, V2. So we can say this is M1 V1 plus M2 V2, and we get this as P1 is equal to 15 times 6 plus M2 is about 25, and this is our minus 10 because the velocity is in opposite direction. Therefore we get that our P1 initial is equal to minus 160. Okay. And it is given that the collision is perfectly inelastic, so both will be moving together. So then they are moving together. This will be 16 plus 25. Let us suppose the velocity is our v. Okay, common velocity is our v. Therefore we can say that our final momentum that's our P2 is equal to M1 plus M2 times V, which gives us 15 plus 25 times V, giving us 10 or 40 V. Now conservation of momentum. Momentum conservation. Initial momentum is equal to final momentum. So we get minus 160 is equal to 40 times V. This gives us V is equal to minus 4 meter per second, which basically means it is moving towards our left side. That's only the negative part. Now we come to our this kinetic energy. So we can say the initial kinetic energy, let us call this as K1, will be equal to half M1 V1 square plus half M2 V2 square, and we can simply substitute the value. This is our K1 and it comes as a half M1 is our 15 6 square plus half M2 is about 25 comes as 10 square. So we get our initial kinetic energy is 1520 joules. Now we come to our kinetic energy final kinetic energy. Let us suppose that's our K2, that will be equal to half M1 plus M2 V square, and we get this as our half 40 and V is our 4 square, which comes as 320 joules. And the heat will be the conversion, because they are going to energy lost, kinetic energy lost will be equal to our heat generated. So you can say kinetic energy lost will be equal to heat generated. So you can say that our K1 minus K2 is equal to our Q. Okay. is our m1 plus m2 multiplied by the specific heat and change in temperature. And so we get this as our difference is our 1520 minus 320 is equal to m1 plus m2 is our 40 times s plus delta t, and it is done now. So we get our delta t is equal to, this will be 1200 divided by 40 s, which gives us 30 upon s. So this is the change in temperature. Next question. Okay, it states that in the presence of a horizontal magnetic field 0.5 Tesla, a wire Mn length perpendicular to the magnetic field of length 20 meter is released as shown. The EMF induced across its ends, it drops 20 meters. Basic figure is given to us. So we are having wire Mn and the magnetic field is into the paper and it is moving downward. Obviously with acceleration equal to gravity g, and when it drops by a distance of 20 meter, we are supposed to find out what will be the induced EMF, and this is directly based on the question. So at this point we are going to find out the velocity, that is v, and initially it was dropped, so u is equal to 0. S we know, a is equal to our g. We can say equation of our kinematics, that is our v square is equal to u square plus 2gh. U is equal to 0, so we get our v square 0 plus 2 times 10 multiplied by 20, which comes as about 400. So we get our v is equal to 20 meter per second. It's in meter, I think. Yeah, 20 meter per second. Now induced EMF, will be equal to BL times V, and all the values are known to us. So magnetic field is given to us as 0.5 and length is about 20 and velocity is about also 20. So we get induced EMF will be equal to 200 volts. Okay. And we can also find out, or we can say, I think that will be sufficient. Next question. It states that across two standard YDSC, that is Young's double slit experiment, setups having the same fringe width, lambda 1, lambda 2 is 1 by 2, d1 by d2 is 2. Then the value of capital D1 and D2 is equal to. So this is our normal YDSC. So this distance is given as our d, and the distance between the fringe width is our small d, and our fringe width is our beta. So we know that for Young's double slit experiment, the fringe width that is our beta is equal to lambda capital D upon small d, and we are having two setups, therefore we can write this beta 1 is equal to lambda 1 d1 and d1, beta 2 is equal to lambda 2 d2 and d2. Okay. And we are given that the fringe width are equal. as per the setup. So we can say that our beta 1 is equal to beta 2, which gives us lambda 1 d1 d1 is equal to lambda 2 d2 and d2. So we can rearrange it, and we can get this as d1 upon d1 is equal to d1 upon d2 times lambda 2 upon lambda 1, and we can substitute the values. So we are given that d1 by d2 is given as 2, and lambda 1 by lambda 2 is given as 1 by 2. So this will be 2. Therefore we get that this ratio is equal to over 4. That was asked for. This is quite straightforward. Next question. Okay, this is an interesting one. It states that there are 2 point charges, one at a vertex and other at the face of the cube as shown. Find the electric flux through the cube. So basic figure is given to us. I drew it as cuboid, it should be cube. Now it's a cube. So we are given 2 charges. One charge is here, this is our 2q, and other charge is at the face of this, and this charge is given as q. And we are supposed to find out the flux through this cube. And we are going to use Gauss law, but specifically for these types of question, we can call that Gauss law as Gauss law for symmetrical faces or symmetrical objects. Gauss law for symmetricity, because Gauss law means the charge should be enclosed. So in this case we are having 2 charges, so we are going to use 2, you can say, surfaces, so that our charge become enclosed. First of all, we are going to focus as this 2q, and for that we are going to draw our 8 cubes. This will be here, this will be here, and this will be here, and it will join like this. Okay. So these are the 8 cubes, and we are interested in this particular charge, that is our 2q. So this is our 2q, and now it is being surrounded by 8 symmetrical objects. It is right at the center. Okay, and therefore we can say that now this 2q charge is shared by 8 cubes. So it means the charge through 1 cube, or we can say the flux through 1 cube, or you can simply say the flux contribution, contribution from 2q through 1 cube through 1 cube. Let's suppose that's 5 1, and that will be equal to 1 by 8. Total charge is our 2 cube upon epsilon naught. Okay, so this comes as our q upon 4 epsilon naught. Now we come to our the phase part. So charge is our, or cube is at the face, and for that we are going to draw so this is our cube and charge is somewhere here. So in order to make it at the symmetricity, we are going to extend with the help of another, we can say, cube, okay, to the right of it, and we are going to draw a cube to the right of it. This is our cube to the right of it. Now this cube is at the exactly at the center of these two cubes. Therefore we can say that our this charge q is shared by two cubes. Therefore we can write that flux contribution from charge q through 1 cube, and let us call this about phi 2. Then this phi 2 will be equal to 1 by 2 q upon epsilon naught. Then simply we can use our Gauss law. We can say that our Gauss law, total flux will be our, because of the enclosed surface. So this is phi 2, phi t will be equal to total phi 1 plus phi 2, which gives us q upon 4 epsilon naught plus q upon 2 epsilon naught, and we get this as our total flux will be equal to, this comes as 4 epsilon naught and equal to 3q. Next question. It states that in the setup shown, the voltage across the zener is 5 volt, current is I, and I2 20 milliampere and 5 milliampere respectively. The value of the resistance R S is in ohms is given as. So basic figure is given to us. So we are having resistance RS, a voltage source of 25, and here we are having a zener voltage, a zener diode, and there is a load resistance RL. and we are given this is current from here is I1, from here is our I2. And we have to remember that Zener diode is basically nothing, it works as a voltage regulator. Like a Zener diode, voltage across Zener diode is given as 5 volt. That means its voltage across Zener our voltage across the Zener diode will be always 5 volt. It is not going to change. That we have to remember. Okay. So we can say that the Zener voltage is our Vz. Therefore, we can write for this loop, let us call this as loop number 1. So we can say for loop 1, we can write our input voltage, that is our V, and here let us suppose voltage drop is Vs. You can say the input voltage V will be equal to our Vs plus Vz. Therefore, we get that Vs will be equal to 25 minus 5, which gives us 20 volt. Now we can use Kirchhoff current law. This is I1, I2, and let us suppose here is our Iz, and this is our point A. So you can say KCL at point A, Kirchhoff current law at node A. So we can write our I1 is equal to I2 plus Iz, and we can find out our this I1 using Ohm's law. You can say our from Ohm's law, I1 will be equal to our, one second, current is given to us, no? Yeah, I1 is given to us 20 ampere. Therefore, we can say from Ohm's law we can find out our RS. RS will be equal to Vs upon I1. So this comes as about 20 upon 0.02, which gives us 1000 ohms. 1 second. Yeah, straightforward. Okay, anyways, not much of necessary went for this I1 and I2. It's simple. Okay, next question. It states that a projectile is projected from point A at an angle of 60 degrees as shown. V is the highest point on the trajectory. If the kinetic energy point A and B and C are Ka, Kb and Kc respectively, then Kc minus Kb upon Ka is equal to, and the basic figure is given to us. So we are having projectile. So this is point A, highest point is our B, and once again same level point is C, and here it is given a velocity of our u at angle of 60 degree. Kinetic energy at A is called as Ka, kinetic energy at B is called Kb, kinetic energy C is our Kc. So we can divide our initial velocity, that is our u, into two components. This is our ux and this is our uy. B is the highest point, so only velocity that will be remaining here will be our horizontal. Vertical component totally vanishes, and ux is totally, you can say, same throughout the this entire motion. And because point A and points, and according to conservation, the velocity of the launch at A should be equal to velocity of landing at C. So we are interested in the ux. So we can say that our ux will be equal to u cos of 60. Okay. So this comes as our u upon 2. Okay. Therefore we can say kinetic energy at A, that is our Ka, will be equal to half m u square. Okay. And kinetic energy at B, is our Ka, this is half m, and here we are going to have only ux square, because vertical component totally vanishes. Therefore we get this as our half m, you can substitute the values. So we get this as our mass of m cos. So this comes as our half, and cos, this is ux is u by 2 whole square. So this comes as our m u square by 8. And kinetic energy at C, velocity at C by conservation will be equal to u, only the direction will be reverse. Okay, that's the only difference. So we can say that Kc is equal to half m u square, and we have to find out our Kc minus Kb upon Ka. So this comes as a half m u square minus m u square by 8, and we have this as half m u square, and we can cancel out this m u square, and m u square. So this comes as our 8 will be LCM, so this comes as our 4 minus 1 upon 8, and this is our 1 by 2. So we get this as our 3 by 8 and 1 by 2, which comes as our 3 by 8 multiplied by 2, giving us 3 by 4. So this is our ratio. Next question. It states that a simple pendulum of length 10 cm completes 10 oscillations in 20 seconds. What is the length required if it were to complete the same number of oscillations in 40 seconds? Nearest value of our centimeter. So in the first case, that is called the time period as t1. So for our case 1, let us call the time period as t1, which will be equal to our total time and number of oscillations, which is equal to 20 upon 10, giving us 2 seconds. And for case 2, let us call that our t2, and once again that will be equal to total time oscillation, which is 4 seconds. But for pendulum, you can say time period for pendulum, that is our t will be equal to 2 pi square root of L upon G, and we can divide this case 1 and case 2. So we can say t1 is equal to 2 pi L1 upon G, T2 is equal to 2 pi square root of L2 upon G. Now we can take the ratio, and we can say that our T2 upon T1 will be equal to square root of L2 upon L1, and from here we can say that our L2 will be equal to L1 times T2 upon T1 and whole square. L1 is given as 10, T2 was 4, T1 was 2 and whole square, and then this gives us that our L2 is equal to 40 centimeters. So this was quite straightforward. Okay, only we have to, for case 1 we have to solve finding the time period as it is. Next question. Okay. So this question states that for the given set of measurement, find the relative error. This question is quite easy, but it is very lengthy one. Okay. So we have to find out relative error. So first we need to determine the mean value and then calculate the average, and that is going to give us the finally the relative error. So let us first of all find out the mean, or we can say mean or average value. Average value, and that will be equal to sum of all measurements divided by number of measurement. Sum of all measurement divided by number of measurements. So you can say that our mean sum will be over 20 plus 19.75 plus 18.25 plus 17.01 divided by 4. This comes as our 18.7525. Now we are going to find out the absolute deviation from the mean. Absolute deviation from mean. So we have our measurements, and then we have our deviation. Measurement first is our 20, so it will be our 20 minus 18.725, that will be common, 7525. This will be coming as 1.2475. Second is our 19.25, and once again this will be equal to our 0.9975. Next is our 18.75, that will be equal to 0.5025. And finally we are having 17.01, which will be giving us 1.7425. Now we are going to find out the mean absolute error. Mean absolute error, which is our all the summation, this summation. Okay, so if you add them, this will be coming as 4.49. So this will be equal to 4.49 and divided by 4, which will be equal to 1.1225. And from here we are going to find out the relative error. So relative error is our mean absolute error divided by mean multiplied by 100. So we have mean absolute error divided by mean times 100. So relative error, we are going to get this as our, for the first case it will be our 1.125 and divided by 18.7525 multiplied by 100, and that will be approximately equal to 6%. And this is our, you can say, the final answer. This was, yeah, only problem was that it was quite lengthy, otherwise the solution is much more easier. Next question. It states that a light ray travels from a prism with a prism angle 8 degree, mu as 1.72, to another prism of prism angle A and mu as 1.9. Find the angle A with no deviation. So basic diagram for no deviation we already know. We have two prisms and they will be connected something like this. And first prism angle, let us suppose, is given as 8. Second prism angle is our A, which we are supposed to find out for no deviation. And we know the standard formula for deviation. You can see for deviation delta is equal to mu minus 1 times A. A is the angle of the prism. And no deviation, for the time being let us assume that this is our A1 and this is our A2. Okay, so we have two prisms, and based on this we can write that our delta 1 is equal to mu 1 minus 1 A1, and second prism we can write delta 2 is equal to our mu 2 minus 1 times A2. And no deviation, means deviation because of the first prism will be cancelled by the deviation of the second prism. This is a basic, okay, or simply we can say that our deviation because of first will be equal to deviation on the second. So we can just put their respective formulas. Mu 1 minus 1 times A1 is equal to mu 2 minus 1 times A2. We substitute the values, we get this as 1.72 minus 1 multiplied by 8 is equal to 1.9 minus 1 times A. And this gives us that the value of A is close to 6.4. Okay, this is for no deviation. Next question. Okay, so it states that out of A, B, C, D, which has more Young's modulus of value. Okay, basic graph is given to us. So we are having, this is our stress and this is our strain, and we have four graphs. This is our D, C, B and A. So this is A, B, C and D, which has more Young's modulus. Young's modulus is represented as our Y, and Y we know is our stress strain. Okay. Or in simpler term, in graphical term, we can write this is equal to slope of the graph. slope of our graphs is a line, so we can say slope of the line. So we can say that the highest slope is of our D, so we can say that our Young's modulus of D is greater than Young's modulus of C is greater than Young's modulus of B is greater than Young's modulus of A. So which one has more? So D is going to have the highest one. Okay. So this was quite straightforward. Next question. It states that a particle undergoes an elastic collision with B of same mass such that B completes a circle till O, top of the circle. The velocity of particle A, that is V, is the least equal to. Okay, this is a very interesting question. So let me draw the basic figure. So let me draw the first of all. This is a circle, and so this is center, and here is our, so this circle is basically up till here. You can just arrange this part, and this is point O, and this is our mass B, this is point B rather, and here it is mass M. And if we draw a vertical line at here, and here it is having a sort of pendulum, okay, and this is mass of A, and it is moving in this direction, and its velocity is given as V, and mass is our same, and this angle is given to us as 60 degree. R is the radius, and we can just complete this one. So this is the center C, and we have this point as M, this point is N, and the radius is given to us here, also is given as our R. So this is the basic question, and we have to find out the velocity of A, that is our V. Okay, so first you have to remember that our point, this mass B should be able to reach this point O. Okay, but the only point which we are interested in is point N. If it is able to cross this point N, then it will be able to reach point O. So we are going to find out the velocity at point N. That is going to help us automatically to derive a conclusion that if it is able to pass this point N, it will be able to reach point O. So let us say that condition at for top of the, you can say just to complete the circle, you can say condition to just complete the circle. And like I said, the only condition we are interested, or point we are interested in, this endpoint. If it is able to cross this endpoint, okay, then it will be able to complete the circle, or we can say it will be able to cross this point O. Therefore, we can say that a condition to just complete the circle, you can say at point N, we can write that, let us suppose here the velocity, it will be moving in this direction. Let us suppose this velocity is our V top. We can say that our mv square top divided by radius r should be equal to over mg. Therefore, from here this m and m cancels out. We can say that velocity at the top will be equal to square root of gr. Now we can use the conservation between the bottom point and top point. So you can see energy conservation. Energy conservation, and this is between the bottom and top. At the top it will be our consisting of our kinetic energy as well as potential energy. At the bottom it will be only the kinetic energy. Okay? And let us suppose at this point it is having a velocity of u. Therefore we can say, and the height potential energy is equal to our 2r height. Therefore we can say that conservation of energy bottom and top. So we can write that energy at bottom will be equal to energy at the top. At the bottom it will be only the kinetic energy, so we can say this is our half m u square. At the top it will be both kinetic as well as potential, so half m v square top plus mg h is our 2r, and we can easily cancel out our m and we can substitute our top. So we get this as our u square is half u square is our half, and v square is our gr plus g, or we can say 2gr. Therefore from here we get that value of u is equal to 5gr and its square root, or we can say this is our minimum value of velocity at the bottom, so that it completes the circle. And from here we can also write that the velocity of b after collision should be at least equal to 5gr. Okay, this velocity b should be having after the collision. Now we come to our collision part. Okay. You can see this is our elastic collision, and the elastic collision is of equal masses. So for equal masses means b was initially at rest and collision was our head on. Okay. So what is going to happen for elastic collision and of equal masses? You can say that there are two particles exchange velocities, or we can say two masses exchange velocity. So it means that velocity of A before collision will be equal to velocity of B just after collision, just after collision, or here also just before collision. So let's find out, or from here we can say that let the speed of A at the collision is v collision. Let's say that velocity of A at collision is, let us suppose, v collision, which is equal to velocity of B, which was u minimum, and this is our 5gr. Okay. Now let's find out what will be the velocity of A as per its own conservation law, because okay, the pencil is almost going to die. Okay, so let me try to complete. So this was our R, and it is going to fall down, and this is our H. So this will be our R cos of theta if this value is theta. Therefore we can say that for A, we can write that our H will be equal to R 1 minus cos of 60. Therefore we get that value of H will be equal to R by 2, and we can use conservation for our A. Conservation for our A, and you can say its kinetic energy of our A will be equal to over half m u square. Potential energy of A will be equal to mg r by 2, and this was our at 60 degree, and we can say at collision it is going to have only kinetic energy of A will be equal to, let us call this as prime, and this will be half m v square collision, and we can equate them. So we can say kinetic energy A plus potential energy A is equal to kinetic energy prime A, which gives us our half m v square mg r by 2 is equal to half m v square coil, and v square coil we know is our 5r, so we can easily substitute, and this goes to be half, half and half. So we get this as our v square plus gr is equal to v square collision, which is our 5gr. So we get that value of v is equal to 2 square root of gr. So this was quite easy, not easy, but a very interesting question. And next, let me hurry up because the pencil is also almost dead. So we have resonance circuit, and the circuit is capacitance, resistance, and we have a voltage source. This is our LCR, 20 Henry. C we are going to find out, this is our 100 ohm, and we know at resonance our impedance of our capacitor is equal to impedance of our inductor. So we can say that our omega naught L is equal to omega naught C. Therefore we get omega naught square is equal to square root of LC. So we substitute it, we get this as C is equal to 1 upon omega naught square times L, and we substitute the values. So we get C is equal to 1 upon 100 whole square multiplied by 20, and this gives us 5 microfarad. Okay, finally. So these were, please remember, all these questions were from the memory based questions. Okay. And so memory based questions were there, so some of data will be here and there, but the basic premise of the questions you get. Okay, so this particular session were having some very interesting questions, at least 5 to 6 were quite interesting, but some were lengthy also. Okay, like for the error part it was quite lengthy. Okay, but still there were around about 27 questions memory based, please remember. So we were able to solve it only for the physics part. Okay, and this session was held on 23rd of January morning as well as evening. Okay. So this completes all the 27, not all the, but memory based 27 questions which we are able to get. Thank you.